the red planet in the next few hours. It should touch down as part of a project called ExoMars 2016. The lander has a short lifespan, but the effects of a successful touchdown are important. It's part of a joint mission with Russia's Roscosmos. Well, for more on this, let's speak to Jim Wild, a space scientist at Lancaster University in the UK. Mr. Wild, thanks for joining us here on TRT World. So, first of all, do you think this thing's going to land?
It'll certainly land. Obviously, what we want is a safe landing. So it's already committed, it's on its way down, it's heading to the Martian surface, and there's a whole series of events that have to happen correctly now for it to touch down safely. First of all, as it starts to run into the atmosphere of Mars, the spacecraft will slow down by friction with the atmosphere, and it'll heat up. And then this heat shield will be ejected, and the speed will have been brought down from 20-something thousand kilometres a second down to a much lower speed of about 20,000 kilometres an hour. It will come down to about 1,000 kilometres an hour. At which point a parachute opens, slowing it further. Some rockets will fire just before the spacecraft arrives at the surface. And then when it's about 2 meters above the surface, moving at about the same speed as a jogger, then the rockets will cut and the spacecraft will drop down onto the surface using a new crushable system. So it has a system underneath the spacecraft, underneath the lander, that's a little bit like the crumple zone on the front of a family car. It's designed to distort and take some of the energy of the impact, and it should cause the lander to land relatively softly on the surface of Mars, where it can start making some measurements over the next few days. But the real key thing is this landing system. The European Space Agency is really trying to test and prove that this new landing system works ahead of its next mission, ExoMars 2020, which aims to put a mobile rover on the surface, which will crawl around and explore the surface of the red planet.
And that's the point, isn't it, Jim, to make sure we don't have a repeat of Beagle 2, which of course did land on the planet, but was then unable to transmit any data. I think it has just been discovered in the past year or so, but it's still not transmitting now. What kind of science are we going to get from this particular lander on Mars?
Well, this lander, as I said, its main mission is to test this landing system, but as a bonus, we're going to get about a week's worth of measurements from the surface, measuring the weather on the surface of Mars, the temperature and the pressure of the atmosphere, and also for the first time measuring the electric fields on the surface of Mars, which may influence how dust moves. Mars is a dusty place. It's the dust storm season at the moment on Mars. So for the first time, there'll be an insight into that. But a lot more science is going to also come from the mothership, if you like. There's an orbiter, the trace gas orbiter, which is going to stay in Mars orbit now for the next few years and start to sniff out and study how methane develops in the Martian atmosphere. And methane on Earth, we know 90% of it comes from biological life on Earth. And so how that's arriving in the Martian atmosphere and what's causing that and what causes it to change is is a really big question and has implications for life on Mars.
Absolutely. Well, we look forward to finding out what they can discover. Jim Wild there from Lancaster University, thank you for joining us.